All right. This is hopefully going to be a very quick video. The idea here is to subtract polynomials. So it's basically like adding polynomials, just with more negatives. So let's think about it, right? So we've got a polynomial, p of x, and we want a polynomial, q of x, such that when you combine them, you get 0. Oh, let's say plus q of x. So this is going to be minus q of x, right? That's what we, or q of x, I guess. So if we just kind of do the stuff that we did before, and remember when we write this notation with p parentheses x, and p is a function, polynomial here, we don't mean multiply the p by the x, right? Keep that in mind. It just is a terrible, confusing, overlapping notation with our other notation for multiplying things inside of parentheses. Two separate things. Anyway, q of x equals minus p of x. Formally, that's what we want. And how might it go? Well, let's say you've got x squared plus 3x, and you want to add something, and get 0, right? So you need adding things only goes with degrees, right? So you have x squared, and you've got an x. And then what do we want? Well, there's an x squared here, so minus x squared. And then this thing, we need a 3 in front of the x, we need to get 0. So this cancels this, and this cancels that, right? So that's how it goes. You can also think of it as minus 1 times x squared plus 3x. And so distribute that any way you like. I'm going to go with a small little grid just to, because I like it. Minus x squared and minus 3x. And so that's just minus x squared minus 3x, right? That's basically it. So let's say I have the polynomials p of x equals 3x to the fourth plus 2x squared plus 7x minus 1. And q of x is equal to minus 3x. Sorry, it's also equal to 3x to the fourth minus 5x squared plus 2x and minus 2.5. Okay, so then p of x minus q of x is, well, you write out that whole same thing. And then you can line them up in kind of a vertical method for adding. And what I would do is, even though I'm subtracting them, I just put a plus, and I would negate every coefficient I see. 3x to the fourth. So the negative of minus 5 is plus 5, so plus 5x squared. Negative of 2x is minus 2x, and negative 2.5 is plus 2.5. And now we add 0, x to the fourth, plus 7x squared, plus 5x, plus 1.5. I just totally, I don't like x cubed. Whatever. Okay. So notice here that what happened is the x to the fourth power, is canceled. So this actually did change. It went from a fourth degree polynomial to a second degree polynomial because we canceled. This could also happen with adding of polynomials. If you happen to have a negative coefficient to the highest degree, that's exactly the opposite partner to the other polynomial's highest degree. It happens. Anyway, so that's our answer. 7x squared plus 5x plus 1.5. So when you combine them, that's what happens. All right. And of course you can graph this stuff. You can do p of x and q of x. You can subtract them, you can add them, you can multiply them. Got all that good stuff. What's left? Dividing. I'm going to take that slow. But yes, we can divide polynomials into polynomials. It's, as you might imagine, a terrible mess, but it is something we can do. And it goes hand in hand with trying to factor polynomials. Once you have a root, you have a factor, and then you can divide that factor into the polynomial to get the rest of the polynomial. We'll go into all that. But that's sort of the next bit. Before moving on, you should be comfortable with adding, multiplying, and subtracting polynomials, right? Make sure you understand that when adding or subtracting polynomials, it's always you're combining coefficients of the same degree terms, right? Multiplying, you're pairing every single term on the left with every term on the right. Just boom, boom, multiply, and then combine the coefficients of the like degrees, right? So that's the main skills here. Play around with it, explore it. Whole new world of pretty graphs and kind of nice stuff.